Welcome back. Let's take a look at regression analysis. This is probably one of my favorite techniques in all of statistics because it deals with plotting things and actually it has a predictive capability that the other tests don't have. And so I used to do mathematical modeling and I like to predict things. But anyway, this technique lends itself to experiments where the variable you impose is continuous. Okay, this is the variable we imposed, and again, let's go back to our brushing experiment. You remember our ANOVA example where we had different ways of brushing. Okay, we didn't touch some of them. We brushed them with our arms, we rubbed them with our fingers, or we shook the bench. We had different ways of imposing height control to these plants. Well, this is different. We've decided on brushing, just waving our arm over these things, and now we're going to vary the number of times a week we do it. And that's something a grower might ask, right? Is okay, great, you told me that brushing works, how often do I have to do this? So you set up an experiment that you do no brushing, this is our control, and then you brush once a week, 3 times, 4 times, or 5 times a week. Okay, that might be reasonable frequencies to consider if you're running a greenhouse. And you measured plant height, that's the response variable. That's, again, that's what you're looking for, is to reduce the height, make the plant stocky and able to stand up in the rain. So because this frequency of brushing is what we call a continuous variable, in other words, it's a numerical variable, 0, 1, 2, 3, 4, 5, so forth like that, not a discrete variable where, again, these are discretely different things, we can actually plot the variable we impose on the x-axis of a plot and then plot the response variable on the y. So whenever you can do that, you can do a regression. So we look for a continuous variable. Didn't spell continuous right, sorry. But anyway, we look for that in our x, and then we can do a regression. And I've just made a plot over here. I'm not even doing the stat test yet. I just made a plot just to remind you of all these things that you had in middle school algebra, I think. Okay, so you have the equation for a line here. What regression does is it fits a line through your data that is a best fit line or a trend line. Okay, and that's easy to do in Excel. If you right click on any of your data points and you say add trend line, you can go through this, and I've already done it, so I won't bother with that, but you can tell it to put a line in, and then that's what we see here in red. This is the best fit line that goes through, and this is the equation for that. So it has a slope of -8, so it's going down 8 units for every 1 unit we go across. And it has an intercept of about 71. That's where it hits the y-axis. Again, middle school algebra stuff here. Another interesting number here is this r-squared deal. And if you took statistics, you might remember this. The r-squared is the coefficient of determination. In this case, it's a number between 0 and 1. In this case, it's pretty darn close to 1, 0.92, say, 0.91. And what it tells us is the degree of correspondence between the x and the y variable. In other words, technically 91% of the variation in the height, the response variable, is explained by frequency of brushing, the x variable, which is pretty good. I mean, 91% of all the variation in height is explained by one thing. It means that 9%, water, light, nutrients, everything else explains the rest. So that's pretty darn good when you see an r-square like that. The two things are very tightly coupled. One is a strong response of the other. Okay, so the only thing I don't know in this case, and you can pause your video and see if you can guess yourself, is, remember, statistical tests always test a null hypothesis that all the treatments are the same. So all treatments are the same is the hypothesis it's testing, and then it's going to give us a probability or p-value that they are the same. That's missing when I just do the graph. I have to do the analysis to actually get that p-value. So we'll do that next.